All right, happy Thursday. Grade 8, Part 2, Dividing Polynomials. Once again, you are smart people, as always. I am not expecting much difficulty here. Essentially, once again, this is going to be pretty basic, but we're going to do a couple of examples just to make sure that we are comfortable. This becomes A times C plus B times C, and that's all being divided by C. I guess I should probably put that in parentheses to show that that whole thing is over C. So basically, all I do here, folks, is take each individual term and divide it. Now, so basically, to get you the idea, how this can eventually end up looking is AC divided by C plus BC divided by C. Hopefully you see what I did there. I just kind of split that up, made those fractions both being divided by C. Pretty basic now. If I do AC divided by C, I know that C divided by C is just going to be 1. Doesn't matter what C's value is. Whenever I take a number and divide it by itself, it equals 1. And then if I take A times 1, because I canceled that out and made it 1, A times 1 is just A, so I end up with A. Same thing happens here in B times C divided by C. Those two cancel out and just become 1. C divided by C equals 1. When I take B and multiply it, by 1, B times 1 is B. So it just becomes A plus B. That's pretty basic. I'm not expecting a lot of difficulty there from smart people like you. When we go on to example 2 definitely ups the ante a little bit. 6x squared y plus 4x to the power of 3, all of that being divided by 2xy. Once again, I can kind of just break it down to make it a little easier. 6x squared y, that being divided by 2xy, and we're going to add 4x to the power of 3, that being divided by 2xy. Okay, so now where do I go from here? Essentially where I end up here, I look individually, what can I take care of? So I look at 6 divided by 2. I can take care of 6 divided by 2. That becomes 3. Then I can look at x squared being divided by x. Remember, similar base numbers, okay? Similar base numbers will just be, the exponents can just be subtracted. X to the power of 2, x to the power of 1. 2 minus 1 is 1. So I'm just going to put x. When I do y divided by y, that just equals 1. Y divided by y is 1. That doesn't change anything. I just end up with 3x there. Now I go to my second division problem. 4x to the power of 3 divided by 2xy. So I look at what can I divide, what works? Well, 4 divided by 2. 4 divided by 2 is 2. Once again, I can subtract the exponents connected with the x to the power of 3, divided by x to the power of 1. 3 minus 1 is 2, so that's going to be x squared. So that takes care of that. Now I look at my y, and there's nothing there, okay? My y is part of the denominator, so down here, it's going to have to become part of the denominator, okay? So that one actually became a fraction. Now this is all just an addition problem, okay? So if I go ahead and just kind of finish off the scratch work here, I actually, when I want to put those together in a simpler form, it's going to become 3x plus 2x squared, and all of that is going to go over y. And that's how that works. And of course, and any time you get something like this, you want to make sure like terms are combined. That's as simple as that's going to get, though. Those are not like terms. All right. Have a good time. Dividing Polynomials, Part 2.